Right? There's one homework problem, and it's almost identical to this. So you need to, this is the John Wooden School of Learning. Does everybody know John Wooden? Okay, Google it. Okay, he's the winningest college basketball coach ever, right? UCLA, 10 championships in 11 years, something like that. Kareem Abdul-Jabbar, Bill Walton, you know. So he said all learning can be broken down into 4 steps: explanation, demonstration, imitation, repetition. Try to imitate what we do here in this homework problem that I'm going to give you later on. Okay. So in this problem, and I broke it, there's like 4, this is on 4 different slides. This is the last example, but I'm just trying to give you as much detail as I can. It says 3 ropes are supporting, meaning they're pulling up at different angles to support a weight of 480 pounds, which is pulling down, right? So if you can picture, right, 3 ropes are pulling up, all at different angles, and then in the middle of that, there's a weight pulling down, which is 480 pounds. Okay. Now, the book in the example gives us the endpoints of the ropes in question. So let me graph those. It's a little bit of an exercise in graphing too. Okay. Where the 480-pound weight is pulling down is the point 0, 2, -1. So how do I graph 0, 2, -1? 0 means X, right? 2 means Y, right? So I would go 0, 2, and then -1 tells you down 1, right? So about right there. 0, 2, -1. Right? That's the point at which there is a rope hanging down, and at the bottom of it there is a weight, and it is 480 pounds. Okay. Now, there's 3 ropes that are pulling up. The first one starts at 0, 2, -1, and it goes to the point 2, 0, 0. Where do I find 2, 0, 0? 2 in the X direction. And just like that, right? So that'll be, the vector is here. It starts there, and it goes there. That one is down. Okay, that point was 2, 0, 0. Okay, the next vector, okay, first of all, they're labeling these vectors. This is the U vector. This is the W vector, which is pulling down. Okay, the next vector, next rope is pulling up in the direction of -2, 0, 0. So right there. Right, and that is the vector V. And that point is -2, 0, 0. Is that right? No, that's actually Z. Okay, then the last rope is pulling up in the direction of 0, 4, 0. So 0 in the X direction, 4 in the Y direction, 0 in the Z direction. Right, that is the vector V. And that endpoint 0, 4, 0. Okay. Now, we're supposed to find the tension in each of the ropes that's pulling up. Well, how many ropes are pulling up, and how many things is it that we don't know? 3 things, right? When you have to solve for more than one variable, what do you need? You need a system of equations. If there's 3 variables you're solving for, how many equations do you need? 3 equations. So we need to come up with a system of 3 equations to solve for these 3 things. Now, we know it's going to involve vectors and a balance of forces, right? So we need to figure out what are the vectors, at least that are determining the directions of these things, right? How can I find the direction of the vector U? Right, turn it into a component form. Right, do the subtraction, right? the direction, these are the directions. Because, what did we use for directions before? We use a direction angle, right? But we don't have a direction angle because we would need to have more than one direction angle since we're in space. Just like in again, modeling the atmosphere, you've got one direction angle as the latitude. That's usually theta in all the equations. The other is the longitude. That's usually a different Greek letter phi. It looks like with the slash in it going up and down instead of across like theta. So we don't have that, but we know that the directions of these things right, for you, it should be in the direction of 2 minus 0, which is 2, 0 minus 2, which is negative 2, and 0 minus negative 1, which is 1, right? Just do the subtraction like we did terminal point minus initial point. Right. The direction of the vector v, do it again. And that will be 0 minus 0, 0, 4 minus 2, 2, and 0 minus negative 1, 1. And the direction of the vector z, which is pulling up in that direction, is negative 2 minus 0, 0 minus 2, and 0 minus negative 1, 1. Right? Understand, these are not the vectors u, v, and w. They're just the directions. Right? The vectors, the magnitude of these is the tension in the cables. It's not the length of the rope. Right? Just like that one we did where it was like 2 ropes that were supporting a weight that was hanging down. We did the system of equations, right? They gave us the dimensions in order to get the angle, but actually there was a tension in the rope, which was the magnitude of the vectors. Okay, so let's see. That's the first step.